High above our planet, in the frigid darkness of the polar winter, a powerful force spins silently and relentlessly, the polar vortex. Invisible to the naked eye, this immense circulation of air is one of the most influential drivers of winter weather on Earth, shaping the climate in ways that reach far beyond the Arctic Circle. This vast swirl of frigid air crowns the North Pole, acting as a guardian that contains the planet's coldest temperatures. Its presence is felt thousands of miles away, as it helps steer the paths of storms and cold fronts, influencing weather patterns across North America, Europe, and Asia. When the polar vortex is strong and stable, it acts like a fortress, locking Arctic cold in place and keeping the harshest winter conditions confined to the far north. The ice and snow remain undisturbed, and the rest of the world experiences more typical winter weather. But when this fortress weakens or becomes unstable, chaos can follow. The cold air escapes its Arctic prison, surging southward and unleashing extreme weather events, blizzards, ice storms, and record-breaking cold snaps, far beyond the polar regions, sometimes reaching deep into cities, unaccustomed to such extremes. The polar vortex isn't a single storm, but a persistent, swirling circulation high in the stratosphere, a spinning top of cold, dense air balanced over the pole. It interacts with the jet stream, the fast-moving river of air that circles the globe, and together they orchestrate the movement of weather systems. The stability of the polar vortex is crucial for predictable winter weather in the mid-latitudes. When it holds steady, winters tend to be milder and more consistent. But when it wobbles or splits, the results can be dramatic and unpredictable. Understanding the polar vortex helps explain why winters can swing so wildly, from gentle, mild days to sudden, record-breaking cold. It's the key to unlocking the mysteries behind some of the most dramatic weather shifts we experience. In this journey, we'll unravel how this distant, swirling force can send waves of Arctic air plunging south, paralyzing cities, disrupting daily life, and testing our resilience against the raw power of nature. The story of the polar vortex is one of science, survival, and the ever-changing dance between the Earth's atmosphere and the world we live in. The polar vortex is one of the most fascinating and powerful features of our planet's atmosphere. It forms high above the Arctic, where the air is coldest and the conditions are harshest. As the northern hemisphere tilts away from the sun during autumn and winter, sunlight becomes scarce, and the Arctic receives very little warmth. This plunges the Arctic into a long period of darkness and extreme cold, with temperatures dropping far below freezing for months at a time. Meanwhile, regions closer to the equator remain much warmer, creating a dramatic temperature difference between the icy pole and the milder mid-latitudes. This sharp contrast in temperature is what drives the formation of the polar vortex. Cold, dense air sinks over the pole, creating a persistent low-pressure area high in the stratosphere. The Earth's rotation then comes into play, causing this air to spin and deflect. This creates a massive counterclockwise circulation, a powerful stratospheric jet stream that acts like a barrier, locking the cold air in place above the Arctic. When the polar vortex is strong, this jet stream forms a tight, well-defined circle, keeping the frigid Arctic air contained and helping to maintain stable, predictable weather patterns in the mid-latitudes. But the strength of the vortex isn't constant. It can weaken, stretch, or even split apart, often due to sudden warming events or disturbances in the atmosphere. When these fortress walls break down, the once contained Arctic air spills southward, surging into regions that are usually much milder. This dramatic escape of cold air can trigger severe winter storms, plunging cities and towns far from the Arctic into sudden, intense cold snaps and snowstorms, reshaping weather patterns across entire continents. The polar vortex's fortress can be shattered by sudden stratospheric warming, or SSW. Powerful weather systems below send waves of energy upward, rapidly warming the stratosphere over the pole by up to 50 degrees Celsius. This disrupts the vortex, slowing or even reversing its winds. The vortex loses its circular shape, sometimes splitting into smaller vortices. Arctic air, once locked away, spills southward. These changes begin weeks before we feel them on the ground. Meteorologists track SSW events as early warnings of coming chaos. The breach in the vortex triggers a chain reaction, setting up extreme winter weather for millions. When the polar vortex collapses, the jet stream below it becomes unstable. Instead of flowing straight, it meanders wildly, forming deep waves. These troughs channel Arctic air far south, while ridges pull warm air north. The result? Wild temperature swings and bizarre weather patterns. Deep freezes in one region, unseasonable warmth in another. Temperatures can plummet by 20 degrees in a day, shocking ecosystems and infrastructure. The once orderly weather map becomes a patchwork of extremes, all set in motion by chaos high above. The Texas deep freeze of February 2021 stands as one of the most dramatic examples of how extreme weather can disrupt daily life on a massive scale. For days, the state was gripped by an unprecedented cold snap, with temperatures plunging far below what Texans are used to. This event was not just a local anomaly, it was the direct result of a powerful polar vortex disruption, a phenomenon that can send icy Arctic air surging far to the south, impacting regions unaccustomed to such cold. The chain of events began high above the Earth, when a sudden stratospheric warming event destabilized the polar vortex. This warming weakened the normally stable vortex, causing it to wobble and split, and ultimately displacing a massive pool of Arctic air. As this frigid air mass was pushed southward, it swept across the continent, bringing with it a wave of cold that Texas had rarely, if ever, experienced. The jet stream, which usually acts as a barrier keeping cold air contained, buckled dramatically. This allowed the Arctic air to surge deep into the heart of Texas, setting the stage for a weather disaster that would soon unfold. As the cold front settled in, temperatures plummeted to record-breaking lows. Texas, a state more accustomed to heat waves than blizzards, found its infrastructure completely unprepared. Water pipes froze and burst, roads became treacherous with ice, and the demand for electricity soared as people tried to stay warm. The power grid, never designed for such extreme cold, buckled under the strain. Millions of residents were left without heat or electricity for days, forced to find creative ways to keep warm in their homes. The blackout became a crisis within a crisis, compounding the dangers of the freeze. Water mains burst across cities and towns, flooding streets and homes, even as temperatures remained below freezing. Roads, coated in ice and snow, became nearly impassable, stranding vehicles and making travel dangerous. Daily life came to a standstill as Texans struggled to cope with conditions they had never faced before. What began as a subtle shift in the atmosphere, thousands of miles away above the Arctic, set off a chain reaction that led to disaster in Texas. The interconnectedness of our planet's weather systems means that changes in one region can have profound effects far away. The 2021 Texas freeze is a stark reminder that distant atmospheric changes can have life-altering consequences, even in places that seem far removed from the Arctic. It highlights the urgent need for communities everywhere to prepare for the unexpected, as our climate continues to change in unpredictable ways. A disturbed jet stream often creates locked weather patterns, systems that stall for days or weeks. When a region is stuck under a deep trough, relentless cold persists, straining heating systems and infrastructure. Storms trapped by these blocks can unleash multi-day blizzards or catastrophic flooding. Prolonged ridges bring droughts and heat waves, drying landscapes and stressing water supplies. The danger lies in persistence. What could be a manageable event becomes a drawn-out disaster. Locked patterns amplify impacts, turning bad weather into week-long crises. Society grinds to a halt as resources are stretched thin. The true peril is not just the weather, but its refusal to move on. Polar vortex disruptions trigger cascading hazards beyond cold and snow. Black ice forms after brief thaws and sudden refreezes, causing accidents and injuries. Power grids buckle under soaring demand and weather-related failures, leading to blackouts. Water mains burst, roofs collapse under heavy snow, and transportation grinds to a halt. Supply chains break down, schools and businesses close, and emergency services are overwhelmed. The initial cold quickly evolves into a multifaceted emergency. These events reveal how vulnerable our interconnected systems are to nature's extremes. While we can't control the polar vortex, we can prepare for its impacts. Forecasters often spot signs of vortex disruption weeks ahead, giving us time to act. Assemble an emergency kit. Food, water, radio, flashlight, medications, and power banks. Insulate your home, know how to shut off water mains, and check heating sources. Plan for school closures, work disruptions, and delayed deliveries. Stay informed, understand weather watches and warnings, and follow official advice. Proactive steps reduce risk and hardship when Arctic air descends. Preparation is our best defense against the wild weather the vortex can unleash. As the Arctic warms faster than the rest of the planet, the polar vortex may become more unstable. A weaker temperature gradient between pole and equator could mean a wobblier vortex and more frequent disruptions. This paradox means global warming might bring more extreme winter cold to some regions. Global weirding replaces predictable patterns with instability and wild swings. The science is evolving, but the message is clear. Our actions may be influencing one of Earth's grandest weathermakers. Understanding the polar vortex is crucial for building resilience in a changing world. We can't control it, but we can learn, prepare, and adapt to whatever the Arctic sends our way.